solids, we should have some idea about the different types of solids that you will be using in this particular topic. So the first one is prism. Here I have shown a square prism. Now we'll look at the nomenclature of this square prism. This part of the prism is called base. Okay. Now this part of the prism, which is again a part of this base, is called base edge, base side, or edge of base. So this is called the base and this part is called the base edge, that is edge of this base. Now this is called the face of the prism. You can notice that the face is rectangular in shape. So all the prisms will have a rectangular face. This is another edge, but it is the edge of this face. Am I right? This face. So that is called face edge. Now this is called the corner. So these are the corners of the prism. Then this is called the top. So hope you got the idea of a prism and its nomenclature. Now we'll see what are the different types of prisms that we'll be using in this topic. Here, the base and the top of the prism is triangular in shape. So this is called a triangular prism. Similarly, this is again, it's a square prism. Now this is a pentagonal prism because the top and the base is of pentagonal shape. So this is called a pentagonal prism. And this is a hexagonal prism because the top and the base is hexagonal in shape. Now you can notice that all these faces of these prisms are rectangular in shape. Okay. So these are the different types of prisms that you will be using in this particular topic. Now we will move to the next solid, and that is a pyramid. Here I have shown a square pyramid. This part of this pyramid is known as the base, and this is called the base edge or the base side or edge of base. And this face is called the triangular face of the pyramid. So all the pyramids will be having a triangular face, whereas prisms were having rectangular face. Okay. Now this is called slant edge, but for the prism it was face edge. Now this is called again the corner. So there are 4 corners for this, and this point is called the apex or vertex of the pyramid. When we hear the word pyramid, we used to think about the pyramids in Egypt, and that is a very good practice. You know why? When students get a question on projections of solids, they usually make a mistake by drawing prism instead of a pyramid and pyramid instead of a prism. So take your time to read whether it is a prism or a pyramid and then start the drawing. Now we will see the different types of pyramids. Here the base is triangular in shape. So this is a triangular pyramid. This is again a square pyramid. Here the base is a pentagon. So it is a pentagonal pyramid. Here the base is a hexagon. So it is a hexagonal pyramid. You can see that all these faces are triangular in shape for a pyramid. So that is why it is called triangular face. And all the edges of those triangular faces are slant. So that is why it is called slant edge. Now we will move to the next solid, and that is a cone. This is a cone. How do you generate a cone? There is an axis over here which is vertical. I'll keep an inclined line like this, and I will rotate this line about this axis. So what happens? It will rotate like this so that a cone is generated. So this inclined line is called a generator. So all these inclined lines I can call the generator of the cone. Now this is called the base of the cone, which is circular in shape, also called circular base. This is called the base rim. This base rim is sometimes called circumference of its base. Now this is called the generator. So we can say that there are infinite number of generators for a cone. Now this is called the axis of the cone, and this is the apex or the vertex of the cone. Next type of solid is a cylinder. This is a cylinder. How do we generate a cylinder? We'll keep this axis which is vertical like this. Then I'll keep a line here which is parallel to this axis. Now I'll rotate this line about this axis like this. So what happens? A cylinder is generated. Now this is called the base of the cylinder. This is called the base rim of the cylinder. This is the generator. This is the axis. And this is the top. And the last type of solid is a cube. For a cube, this is called the side or edge. This area is called the face of the cube, and this is called the corner of the cube. Here all these 6 areas are called the faces of the cube, because we can't differentiate between the base, top and face of a cube. Similarly, all these lines are called the sides or the edges of the cube. Hope all the types of solids are now clear to you. Now we will see how to draw a 3D solid into 2D. That is, how to convert a pictorial view of a solid into orthographic projection. First we will draw the pictorial view. And this is the pictorial view of a square prism. So I'll name the top as ABCD and the base as 1, 2, 3, 4. In the top view, if I project it to HP, we'll get a square. Am I right? How will you name these points? You can see that the line A1 is projected to a single point over here. So how will you name this point? When you view from the top, the point which is nearer to you is A and the point which is away from you is 1. So you will name this point as A brackets 1, which means that the point A is nearer to you and the point 1 is away from you. Similarly, this point is B brackets 2, this is C brackets 3 and this is D brackets 4. Again, the front view is projected onto the VP. So you get a rectangle over there. So how will you name this point? It is this line BA which is projected to this point, correct? So in the front view, the point which is nearer to you is B and the point which is away from you is A. So you will mark this point as B dash brackets A dash. Similarly, this point is C dash brackets D dash, and this point will be 2 dash brackets 1 dash, and this point will be 3 dash brackets 4 dash. Hope these projections are clear. Now we will see how to draw this orthographic projection on a paper. You will draw the XY line. In the top view, you can see this square. Am I right? So you can draw that square below the XY line. You can mark these points like this. This will be A brackets 1, B brackets 2, C brackets 3 and D brackets 4. Again, in the front view, you can see this rectangle which is above the XY line. So you can draw that rectangle above the XY line and mark these points as B dash brackets A dash, C dash brackets D dash, 3 dash brackets 4 dash and 2 dash brackets 1 dash. Hope the naming part in solids is clear for you. Now let us see the simple positions in solids. So what is meant by a simple position? I shall explain to you what is a simple position through some 3D figures. Now look at this. This is a square prism resting on HP such that its axis is inclined to both HP and VP. If you are asked to draw the projections of this solid in this configuration, it will be very difficult because you can't see the base edge or height in any of the front or top views. So that is the problem. So we'll see how to go to a simple position. Now this is called a simple position in which you can see the base edge in the top view and the height of this prism in the front view. So if the axis is perpendicular or parallel to one of the reference planes, you can see the original dimensions of the solid in any of the views. That particular position of the solid is called a simple position. Okay. From simple position, we move to the complicated positions of the solid. So remember that if the axis of the solid is inclined to any of the reference planes, we first keep the solid in its simple position and tilt it to that particular position. Hope the idea is very clear. Now we'll see the different types of simple positions, that is prisms resting on HP. Here we'll consider a triangular prism. In this case, the rectangle face AC31 is parallel to XY line. What it means? In the top view, our XY line can be treated as VP. So the rectangle face AC31 is parallel to VP. Now here, a rectangular face is kept perpendicular to VP. So the faces A, B, 2, 1. In the next case, a rectangular face AC31 is kept inclined at an angle phi to VP. And here, two rectangular faces are kept equally inclined to VP. If I draw a line here, this particular angle and this angle will be same. So these two rectangular faces are making the same inclination with VP. Next is pyramids resting on HP. So I'll take a triangular pyramid over here. Here you can see that the base edge AC is parallel to VP. Very clear. Here the base edge AB is perpendicular to VP. Here the base edge AC is making an angle phi with VP. Here the base edges CA and CB are making equal inclinations with VP. Hope this is clear. Now let us see what happens if a prism resting on HP in a particular simple position is tilted. So that is case 1. Here the triangular prism is having a rectangular face AB21 on the left side, which is perpendicular to VP, and on the right side you can see 2 points C and 3, where C is on the top and 3 is at the bottom. Look at the front view. C dash is on the top and 3 dash is on the ground or HP. So from this position, if this solid is tilted to the right, what happens? It will rest on this particular point. Which is that point? It is 3 dash. So which is this point 3 dash? It is a corner of the prism. So the base is 1, 2, 3 and it is lying on one of its corners of its base, that is 3 dash. And again, what happens if I make this prism lie down? It lies on 3 dash C dash, which is nothing but the face edge of this prism. So we can conclude that if you keep one of the corners of the prism to the extreme right side like this, and if you just tilt it, it will rest on its corner, and if you make it lie down, it will rest on its face edge. Is it clear? Now we will see the next case. Here, the triangular prism is kept such that the rectangular face is on the right side and it is perpendicular to VP. So on the top you have AC, the edge AC, and on the bottom you have 1, 3. Okay. Now what happens if I tilt this to the right? If I tilt this to the right, it will rest on this particular edge. This is an edge. Why? Because it is 3 dash 1 dash. It is a line. So it is an edge. What edge is it? It is the base edge. The base is 1, 2, 3. So 1, 3 is the base edge. Okay. And what happens if I make it lie down like this? It will rest on 3CA1, or in the front view 3 dash C dash A dash 1 dash, which is nothing but the face of the prism. So we understood that if you keep the rectangular face of the prism on the right side like this, and if you just tilt it to the right side, it will rest on its base edge, and if you make it lie down, it will lie on its rectangular face. Now let me ask you one more thing. If I keep the simple position like this, and if I tilt it to the left, what happens? It will rest on the corner 2 dash. And if I make it lie down to the left, it will rest on 2 dash B dash, which is the face edge of the prism. Now let us see what happens to a pyramid when it is resting on HP in a particular simple position and if it is tilted. This is a triangular pyramid with the corner kept to the extreme right side. And if you tilt it, what happens? It will rest on its corner. Very simple. It's very easy to understand, right? And if I make it lie down on XY line, what happens? It lie on C dash O dash, which is nothing but the slant edge of the triangular pyramid. Okay? So if any pyramid is kept like this with the corner to the right side, and if you just tilt it, it will rest on its corner, and if you make it lie down, it will lie on its slant edge. Now let's see the case 2. Here, the triangular pyramid is kept such that the base edge is kept perpendicular to VP and it is on the right side. So here the base edge is BC. In the front view you can see that base edge has a point which is marked as B dash brackets C dash. Now if I tilt this to the right, what happens? It will rest on B dash bracket C dash, which is nothing but the base edge. If I make it lie down on XY line, it will rest on B dash C dash O dash, which is nothing but the triangular face of the pyramid. So if you want the pyramid to rest on its base edge or triangular face, you have to keep the simple position such that the base edge is kept perpendicular to VP. If this solid is tilted to the left side, what happens? It will rest on this corner A dash. And if it is made to lie down to the left, it will rest on A dash O dash, which is nothing but the slant edge. Hope the simple positions of pyramids and prisms are clear, and you have to choose the simple position of the solid according to the question. You have to check whether the solid is resting on the corner, the base edge, the triangular face, the slant edge, or the face edge, and according to that you select the simple position of the solid. Okay. Now, this is the simple position of a cone resting on HP on its circular base. What happens if this is tilted to the right? So what is this? It is a point on the circumference of its base, or it is a point on the rim. Is it clear? Now if I make it lie down to the right side, what happens? It will rest on one of its generators. Hope this is very clear. Now let us see what happens if we tilt a cone which is resting on VP. So this is a cone which is resting with its base on VP, so that you can see the circle in the front view, and in the top view you can see a triangle. If I tilt it like this, it will rest on VP on a point on the circumference of its base. And if I lay down the cone like this on VP, it will lie on a generator on VP. Okay? In all the previous cases, the solid was resting on HP. But in this case, the solid is resting on VP. We can also keep prisms and pyramids on VP like this. Hope you have understood the basic simple positions of solids. Thank you for watching. Happy learning.